Hello all, let's start section 7.1. 7.1 we will cover radian measure. If you remember, since I start chapter 6 trigonometry, we talk about measuring an angle, and very briefly I talked a little bit about radians in the first lecture. But mainly what we used to measure an angle was degree. There are two types of units. Let me write down two types of units that you can measure an angle, correct? One of them was degree that we used in chapter 6, and the other one is radian. We use measuring angle by radian when we do more analytical type of a study of the trigonometry. After this, in your pre-calculus book, and you go to calculus 1, 2, 3, differential equations, whatever you study, if you deal with trigonometry, if you see, you will measure by radian. Everything is in radian, correct? Then let's understand what is the meaning of radian. If I draw a circle here for you, I have a circle, and in this circle I draw a central angle. This is my radius, and I draw another radius here, correct? It creates an angle theta. Of course, from here to here, that's the arc in front of my angle, which I'll name it S. Correct? Now, what is radian? Radian measure, let me put the definition for you. Radian measure of angle theta is the ratio of the arc length and arc length, it means S, right? To the radius R. To the radius R. Correct? It means theta equals S over R. If I write this definition in mathematical way, theta equals S over R. If you divide your arc length, it means from here to here. This is my arc length, whatever that arc length is. By what? By the radius of the circle. This R, it gives you the measure of the angle in radian. Please do not confuse this definition with 1 radian. Later in my lecture, in next 10-15 minutes, I'll introduce to you what is 1 radian, or how much is 1 radian in terms of degree. But right now, in general, what is a radian? A radian means the measure of the angle that comes through if you divide the arc length by the radius of your circle. Correct? I can do a quick example here, but later we will cover more good examples. But really an easy example is, if I give you like this a circle, if I give you the arc length and the radius of this circle, easily you can say how much is the measure of your angle in radian. For example, in this example, the arc length is 15 centimeter and your radius is 6 centimeter. This is your angle theta. They are asking you how much is theta, correct? Based on my formula, theta equals S over R. It means my S is 15 centimeter over R, which is 6 centimeter. Centimeter cancels out with centimeter. You can divide 15 and 6 by 3. 3 goes 2 times to 6 and 3 goes 5 times to 15. It means your measure angle is 5 over 2. But what is the unit? Radian. After this, I will just write rad. It means radian. Correct? This is how you find the measure of an angle in radian. Just what to do, you need two parts of the problem. You need to know two dimensions, the arc length and also the radius. If I know these two, I will divide them, make a ratio. That's the measure of my angle in radian. Correct? Now, a very important topic. Proving. I will do the proof. You are not required to learn the proof. Why I'm doing the proof? Because I see a lot of students in my calculus classes or other classes. They have kind of problem of understanding what is radian, how to convert radian to degree, degree to radian, or even how to read the unit circle. I said, what does it mean 2 pi, 3 pi, 6 pi over 7? What is this? Now that's why I want to do a proof here for you to show why it's important, and it helps you to understand and to learn the converting formula to convert a degree from a degree to radian or radian to degree. Proving of the formula. To convert degree to radian. To convert degree to radian or vice versa. Radian to degree. Correct? It's not a difficult proof. It's really an easy proof. Correct? Again, I'll draw a circle here for you. This time, I will create a 90-degree angle here, like this. It's 90 degree, and I'll name it theta. Of course, this is the arc length. I'll name it S. From here to here, that's my arc length, and I'll name it S. And also, this is my R, the radius. Correct? Now, the main formula that right now I know about the radian is theta equals S over R. Correct? Let's name this formula number 1 or equation number 1. If you remember from school geometry, if I ask what is the formula for the circumference of the circle, the circumference of the circle is 2 pi r, right? It means the length of the circle starting from this point all the way coming back to this point, right? It's 2 pi r. We know it from geometry, which is the circumference of a circle. C equals 2 pi r, right? You saw this before. Now, If I ask you, how much is the length of S? It shouldn't be difficult for you to understand because 90 degree is a quarter of a circle, correct? It's a quarter of the circle. In formula number 1, if I solve this formula for S, of course I will multiply both sides by R, then S equals theta times R, right? On the other hand, my S is 90 degree, correct? Well, let me go this way for you before this. Then I can write S equals theta. Your theta, not this step. Let's go different way, make it easier for you. Theta equals S. How much is your S? Your S is actually 1/4 of this circumference of the circle, correct? 1/4 of 2 pi r. Agree? Because if the circumference of a circle is 2 pi r, if you take 90 degree out of it, it means you take 1/4 of that circumference, which is your S. Then I'll replace my S with 1/4 of 2 pi r over another r, which is my radius, correct? Then I can say theta equals 1/4 of 2 pi r means 1/2 of pi r, right? 1/2 pi r over another r, correct? This r cancels out with this r, then theta equals pi over what? 1/2 of pi or pi over 2. How much is theta actually? If you see, my theta is 90 degree, correct? Then 90 degree equals pi over 2. Here you go. You found a relation between degree and radian. 90 degree means pi over 2, correct? 90 degree is pi over 2, correct? Even you can put here radian. Let's name this one equation number 2. Now, from this equation, if I multiply both sides of my equation by 2, correct? I have 90 degrees equals pi over 2 like this. If I multiply both sides by 2, this 2 cancels out with this 2. 2 times 90 degree gives you 180 degree. 180 degree, we name it pi radian. It means if it's a line like this, if it's an angle, this is 180 degree. In terms of radian, we call it pi, correct? This one is actually the main formula for you. You have to memorize this. 180 degree is pi radian. Now, you can do a lot with this equation, at least for few angles that I want to prove for you, correct? Few angles at least. For example, if I divide both sides of this equation by 3, what's happening? Let's say 180 degree divide by 3 equals pi over 3 radian, correct? 1 time, 6 time, correct? It means your 60 degree is pi over 3, correct? if you divide both sides, for example, by, let's say, another angle, maybe, um, let's divide by 4. I have 180 degree equals pi radian, right? If I divide both sides by 4, 1 time, 4 times, 5 times, it means 45 degree in terms of radian means pi over 4. If you go to the last page of your book, there is a unit circle picture there that you have also the angles in degree, and also beside that they shows the angle in terms of radian. Pi over 6, pi over 3 means 60 degree. Pi over 4 means 45 degree. Pi means 180. Pi over 2 means 90 degree. Correct? This is how you measure an angle in radian. Now, again, I want to find a good relation or good two formulas to convert any angle that's given in degree to me to radian, or vice versa. If it's given in radian, I should easily convert to degree. Correct? The few examples that I did, they are like I cannot call it a standard angles, but the angles that we deal a lot with, like 45, 60, 90, 180, 270, 360, right? These are the angles that I should know how much they are in radian. But there are many other angles that you can convert from degree to radian or from radian to degree. For example, what is 55 degree? What is 57 degree? What is 32 degree in terms of radian? I want to create a good relation here for you, and you need to memorize those, correct? My main formula is 180 degree equals pi radian. I will write completely radian. Now, let's divide both sides of this equation by 180 degree. It means I want to find what is 1 degree in terms of radian, correct? You see, I will divide both sides by 180 degree or by 180, correct? Not degree, just let me erase the degree, just by 180. These two cancels out, then I can say 1 degree equals pi over 180 radian, correct? This relation is really important relation for us, that we know how much is actually 1 degree. And if you divide pi by 180, approximately the value is 57.3 degree. We never use this decimal number after this in our analytical studies here. We just keep it as a fraction like this. But to understand, 1 degree is 1 radian, actually, correct? 1 radian is 57.3 degrees, correct? Not here, sorry. The next one, I jumped a little bit. 1 degree is pi over 180. Same formula, 180 equals pi radian, right? This time, let's divide both sides by pi. These two cancels out, then I can say 1 radian equals 180 over pi. My bad, I used that there, which is approximately 57.3 degree. 1 radian is 57.3 degree. We never use this decimal number, but at least it's good to know how much is what 1 radian, correct? We always use the fraction form. these two formulas, 1 degree equals pi over 180 and 1 radian equals 180 over pi, are the main two formulas that you can convert degree to radian and radian to degree. How? I'll put some notes here for you. To convert from degree to radian, number one, note number one, to convert from degree to radian, multiply the given degree multiply the given degree by pi over 180. Note number two, to convert from radian to degree, multiply the given radian by 180 over pi. Very simple. You can change any angle from degree to radian or from radian to degree. Correct? Few examples that I want to do here for you. Example number one. Convert 150 degree to radian. Correct? We are converting the degree to radian. I will multiply my degree with pi over what? 180 degree. Correct? Here you have the radian too. Degree cancels out with degree. 0 cancels out with 0. You can divide both by 3. 5 times, 6 times. It means 150 degree is 5 pi over 6 radian. Correct? Next one, example number 2. Convert 11 pi over 6 to degree. 11 pi over 6 equals, I will multiply my radian, which is 11 pi over 6, with, I'm sorry, 180 over pi. Correct? Pi cancels out with pi. 1 time, 3 times. Correct? 11 times 30 gives you 330. 330, and your unit will be degree. Correct? This is how you convert from radian to degree and degree to radian. Now, how much is 1 radian? Of course, you may tell me, oh, you just told us 57.3 degree. Yes, but what is the definition? What you call exactly 1 radian? 1 radian is the measure of the central angle of the central angle that intercepts an arc equal in length to the radius. Of the circle. Let's complete. Radius of the circle. Let me show you in picture. What does it mean, this definition in picture? If I create here a central angle, correct? This is the radius. This is the radius, right? This is angle theta, and this is S. Correct? This is your theta. If S is equal R, the measure of this angle theta, I call it this measure 1 radian. When you can call it 1 radian? When the length of the radius and the length of the arc, which is created by two radius, correct? They are equal to each other. You call this one 1 radian. Correct? And you know the measure of 1 radian, which is 57.3 degree. Correct? You may think if I draw a bigger circle, maybe the measure of the radian is changing. No. As long as your S is equal to R, it doesn't matter what is your radius, the radius of the circle is. If it's 4 centimeter or 4 meter, you will end up with the same answer. And we call it 1 radian. Correct? The next formula is the arc length formula. Again, this is my circle. And I'll create here an angle. Correct? Let's name it theta. This is R, this is S. We already know that theta equals S over R. If you multiply both sides by R, you see your S equals R theta, or theta times R. This is the formula that you can calculate the arc length. If the radius is given to you, and if you know how much is the measure of your angle in radian. Correct? One more formula, then few examples. Sector area formula. If this is my circle, here I have theta, this is R, this is S. If I want to calculate this part, this area, we call this area the sector area, a sector of your circle. Correct? how to calculate the area of that sector, I will do an easy proof for you here again. Then I'll give you the exact formula. One thing that we know, if the radius is getting bigger, of course, and the length of the arc will be bigger and bigger and bigger, correct? It means the area, if I name it this area A, the area A of a sector is directly proportional to the measure of its central angle. If the measure of this angle is small, you get a smaller area sector. If this angle is bigger, you get a bigger area sector, correct? It means, to write down, the area of a sector directly proportional to the measure theta of its central angle. Translate this, if you remember from algebra, direct variation or direct proportional. If I name the area as A, it's directly proportional to theta, correct? And every time, I hope your professor in algebra, he covered this part for you. Every time that you write a direct variation formula, you need a constant K, right? If I remember, y equal kx was your direct variation formula in algebra. The area of a sector is directly proportional to the measure of the central angle, correct? That English language, this easy to write in mathematical form. A equals K times theta, correct? The area of a circle is pi r squared. That's the formula for the area of the circle, right? Area of the circle. And when I'm talking about the area of the circle, it means all the area that you have, this area, correct? This is pi r squared from geometry. And also, when you are talking about the area, how much is your theta? Your theta, you do a full round. What is a full round in terms of radian? It means your theta is 2 pi, right? Because pi is 180 degree. 2 pi is 360 degree, correct? Let's replace A and theta with its values, and let's name this one equation number 1. Then I can say pi r squared equals k times 2 pi instead of theta. Let's solve this equation for k. It means divide both sides by 2 pi. You can say k equals, pi cancels out with this pi, 1/2 of r squared. Let's name this one equation number 2. Let's take the value of k from equation number 2 and plug it in equation number 1. Then your equation number 1 becomes A equals 1/2 of r squared theta. In your book, they don't show you this proof. They just put this formula for you. They just put this formula for you, and they're asking you to memorize it. Please memorize this formula. What is this formula? This is the sector area formula. Area formula. A equals 1/2 r squared theta. Correct? Let's do an example. I'll try to copy an example from your book. You have a circle. Example. You have a circle that the radius is 3 centimeter, correct? And your theta is 4 pi over 5, correct? Something like this, 4 pi over 5. That's your theta. They are asking you to calculate the area of the sector. Formula: A equals 1/2 r squared theta. It means A equals 1/2 of 3 squared times theta, which is 4 pi over 5. Correct? Then A equals 1/2 of 9 times 4 over 5 pi, or 4 pi over 5. 1 time, 2 times 9 gives you 18. Then A equals 18 over 5 pi, the area of the sector. Usually on the test, on the quiz, we are not asking you to change this to decimal. No, that will be your final answer in fraction form. Correct? Another good example. Example. A circle is given to you. The radius is 5 centimeter and the angle is 120 degree. They are asking you to find the area sector. Remember, if your angle is given in degree, the first step is to convert your angle from degree to radian, because the formula that we are using to calculate the area sector, it's for radian, not for degree. If the angle theta is given in degree, step number 1 is to convert the degree to radian. Correct? 120 degree equals 120 times pi over 180, which we did before. Cancels out. Divide by 6 2 times, 3 times. It means 120 degree is 2 pi over what? 3. Now, the area sector formula, A equals 1/2 of r squared pi, r squared theta, sorry. Then A equals 1/2 of my r, 5 square, times 2 pi over 3. 2 cancels out with 2. 5 square is 25. Then A equals 25 pi over what? 3, the area sector of your formula, which if you wanna change it to a decimal, it will be 26.18 centimeter square, correct? Because you have to put the unit. It's also the centimeter becomes, when you are squaring the radius, whatever the unit of your radius is, it becomes a square. And you know, we calculate the area in a square, correct? That will be the area sector formula. Last topic of this section, 7.1. Angular speed and linear speed. What is angular speed? What is linear speed? Correct? Suppose we have a wheel like this. If I can draw a good wheel here for you, not a good, at least a wheel. This is a wheel, right? Suppose we have a wheel, correct? And it rotates like this about its axis, which is, this is your axis, correct? If I draw it better, it rotates like this. It's rotating. When it rotates like this, it creates, of course, in a positive rotation. When it rotates like this, it creates an angle, what? Theta. Correct? And this rotation is in a constant rate. Correct? Remember, my rotation is in constant rate. Because later when we talk about instantaneous, it will be something really difficult. Not difficult, kind of complicated. We need calculus for that. But here, the rotation is in a constant rate. Let me write down for you to memorize. Not memorize, to at least understand. Suppose a wheel rotating or rotates about its axis, like this picture that I draw, diagram that I draw for you, at a constant rate. That's important. Your rate is constant rate, not instantaneous. Correct? Now, two things. If a radial line turns through an angle theta, in time t, then we use this Greek letter again. It's not a W. We call it omega. The name of this letter is omega. Then omega, which is your angular speed, is equal t theta over t. That will be the formula for the angular speed. Correct? These are the radials. If it rotates, in a constant rate on an angle theta, then your angular speed is omega equals theta over t. And if I draw the same shape, again a wheel, again an axis, this time if a point, for example, if I name this one a point P, correct? Rotating on the wheel travels from one point to another point, we call this one linear speed, and it travels this distance, correct? We call this one a linear speed. If a point P, let's name it P, on the rotating wheel travels a distance d, and time t. Of course, when you travel a distance, it takes time, right? And a time t, then your in linear speed formula will be v equals d over what? D over t. This is linear speed. This was angular speed. Correct? These are the last two formulas in your section 7.1. Let's do an example. Example number 1, I'll copy it from your book. A circular gear and a motor rotates at the rate of at the rate of 100 RPM, 100 rounds per minute, correct? Or you can say, you can translate your R as a revolution, correct? Your R means revolutions. RPM, revolutions per minute. If you take a physics class, you will see a lot of these units, correct? Revolutions per minute. It means how many rounds or how many rotations per minute. Part A of the problem. What is the angular speed? What is the angular speed of the gear in radians per minute? Speed and radians per minute. Correct? look, each revolution of the gear is actually 2 pi, right? Each revolution is what? 2 pi. One round. We call it one revolution. Correct? 2 pi radian. Now, my angular speed formula, omega, equals theta over what? T. In this formula, the angular speed is given to you. Omega is 100 RPM. Correct? Also, T is given 1 minute. How I should know? Because they said, what is the angular speed of the gear in radians per, per minute? Correct? If you solve your equation for theta here, for theta, of course, we will multiply both sides by t, right? These two cancels out. Then I can say theta equals omega times t. Correct? Then theta equals omega, which is 100, times t, one revolution, which is 2 pi, correct? Your t is one revolution, which is 2 pi, which gives me 200 pi radian. Correct? Now, omega equals theta over t. It means my theta, which I found, my angle, 200 pi radian over 1 minute. Correct? Which gives me 200 pi radian per minute. That will be the angular speed in 1 minute. Correct? This was all about section 7.1. There are not any difficult formulas. Few things that we learned here. First, we can convert a degree to radian or vice versa. Number two, we can find the arc length if the theta and the radius is given. Number three, we can find the area sector of a circle, but in radian. 4, angular speed and linear speed. Correct? I'll stop the lecture here and see you all in section 7.2.